In this video, I'd like to show how we can use binomial expansion to approximate square roots. And in particular, I'm going to use the binomial expansion of 1 plus 3x, the square root of 1 plus 3x, to approximate the square root of 130. Okay, well, what I want to think about first is about the square root of 130. Well, notice the square root of 130 is equal to the square root of 1.3 times 100, which is equal to the square root of 100 times by the square root of 1.3, which is 10 lots of the square root of 1.3. Well, this might seem a strange thing to do, but then if we look carefully, we notice that there's some similarities between these two. And in particular, if we let x equal 0.1 or 1/10, then the square root of 1 plus 3x is just the square root of 1.3. So if we let x equal 0.1, this is the square root of 1.3. Okay, so let's find the binomial expansion of 1 plus the square root of 1 plus 3x. Well, this is 1 plus 3x to the half. So this is 1 plus a half of 3x plus a half times minus a half over 2 factorial lots of 3x squared plus a half times minus a half times minus 3 over 2 over 3 factorial lots of 3x cubed. And there's higher order terms, but I'm going to stop there. I didn't really need this bracket, so I'm going to get rid of this bracket here. And let's simplify this a little bit. So this is 1 plus 3 over 2x, and this is minus 9 over 8x squared, and this is plus 27 over 16x cubed. Let's think about when this is valid. Well, this is valid when 3x is between negative 1 and 1, or x is between minus a third and a third. Okay, well, what did we say here? We said that when x equals 0.1 or 1/10, then the square root of 1 plus 3x is equal to the square root of 1.3. So if we substitute x is 1/10 into our binomial expansion, we should get a good approximation of the square root of 1.3. And notice it's important that this is only going to be a good approximation if x is between negative a third and a third, but 1/10 definitely is between negative a third and a third. So making the substitution, we get that the square root of 1.3 is approximately equal to 1 plus 3 over 2 times 1/10 minus 9 over 8 times 1/10 squared, so 100, plus 27 over 16 lots of 1/10 cubed, which is 1,000th, plus some terms here. But notice these terms are going to be very small. And if we want to approximate the square root, then we're going to get quite a good approximation because these things here are only going to be very, very small numbers. Okay, so let's start to work this out. And the beauty of this is we can actually start to calculate this without a calculator. So this is going to help us approximate a square root without actually using our calculator. Well, this is equal to 1 plus 3 over 20 minus 9 over 800 plus 27 over 1,000, 16,000, plus some very small numbers. I'm writing a common denominator there of 16,000. This is 1 plus 2,400 over 16,000 minus 180 over 16,000 plus 27 over 16,000. And then in theory, we could calculate this quite easily without a calculator. So this ends up being 1.140437.5. So what have we got? We have that the square root of 1.3 is approximately 1.140437.5. But I asked about finding an approximation to the square root of 130. And notice the square root of 130 is 10 times the square root of 1.3. So the square root of 130 is equal to 10 times the square root of 1.3, which is therefore approximately equal to 10 times 1.140437.5, which is 11.404375. And that's an approximation of the square root of 130. Well, if you get your calculator and you check the square root of 130, you will get 11.401754 to 6 decimal places there. And notice how close we are. We've got the square root of 130 correct 2 decimal places by using binomial expansion. So that's not bad at all. And if we wanted to, we could actually calculate the percentage error here. So how far is our approximation out of the actual square root of 130? Well, how will we do that? Well, we do our approximation divided by our actual value of 100 square root of 130, multiplying this by 100. That gives us 100.02299 to 5 decimal places. So how good was our approximation? Well, that is an error of 0.02299%. So we've got an extremely high degree of accuracy for approximating a square root, and we didn't really need to use a calculator for that, which I think is quite interesting and quite a useful thing that we can do using binomial expansion.